All right, so we're going to do some detention time problems today. This is also known as the hydraulic retention time. We're going to do a couple of questions, but before we get into it, I want to talk a little bit about what detention time really means. I know when we're preparing for our exams, it's easy to get caught up in the calculations and the formulas, but you always need to relate it back to how you would use this on a day-to-day basis at the water or wastewater treatment facilities. So detention time, the definition is that it measures the length of time a particle of water remains in a tank, pond, or pipe. So we're basically measuring the time elapsed from the moment a particle enters the tank to the moment when it leaves the tank. And we use it in a lot of different cases. One of them is treatment efficiency. So, for example, in sedimentation tanks, a certain amount of time is needed for the suspended particles to settle out. So, an operator will use detention time formulas to understand how much time it will be needed for the particles to settle out in the tank. In biological treatment processes, such as activated sludge systems, a sufficient time is required for the microorganisms to break down organic matter. So treatment efficiencies is one place that we'll really look into detention times. Another place is chemical reactions. Many treatment processes involving chemical reactions such as chlorination for disinfection or coagulation for removing particles, we're going to be looking at detention time. And we need to look at this number to understand and ensure what the necessary time is for these reactions to occur to ensure that the reactions are complete and achieve the desired treatment objectives. So detention time is equal to the volume over flow. Okay, let's do a practice problem. All right, so the first question we're going to look at is saying, what is the detention time in days for an aerated lagoon that is 120 meters long, 50 meters wide, and 1.45 meters deep if it receives a flow of 233 meters cube a day? Now, remembering our detention time formula is up here. So I'm going to write it down here as well. We are looking for detention time in days. That's what we're looking for. And to calculate this, our formula requires us to find the volume, and it requires us to find, whoops, this is incorrect. This should be flow. And to find or to input the flow. So as you guys know, before I start any problem, the first thing I like to do is kind of draw out the scenario that we're dealing with and write all of the given information on the diagram just so I have a better picture of what's going on. So I know that we have a lagoon of some sort, and let's draw that out. So we have a lagoon of some sort, and we're given that the lagoon is 120 meters long. We're given that it's 50 meters wide, and we're told that it's 1.45 meters deep. And we're told that it's receiving a flow at 233 meter cubes per day. Okay, immediately I'm noticing our units are all meters. This is good. I know that I may not have to do any unit conversions. So the first thing I'm going to do, though, is to be able to solve and use this formula, we do need to find the volume. So let's do that right now. So the volume of this lagoon is going to be length times width times height. Okay, our length is 120 meters, our width is 50 meters, and our depth is 1.45 meters. Again, whenever I'm, ever using a formula, regardless if it's an easy one, volume, maybe we've done it 100 times, I'm still always going to put in my units not only does this ensure that my units are all consistent, but it also ensures that I'm using the right formula and I'm getting the right end result. So let's put this into our calculators, and we get that the volume is 8,700 meters cube. Again, this is just a friendly reminder. I'm sure you guys have seen our other videos, but we do get asked this quite a bit whenever we're multiplying the same unit. So right now we're multiplying meter by meter by meter. Whenever we multiply, we're adding the super exponents. And right now there is no super exponent, so that means it's 1. So we're adding these, so that's 1 plus 1 plus 1. That gives us 3. If we're dividing units of the same type, then we're subtracting the superscript. So just as a example, if we were going like 5 meter cubed divided by 2 meter squared, what we would do, since we're dividing of the same units, then we're going to be subtracting our superscript. So it would be, the unit would be meters. All right, so we have our volume. Back to the problem. We have our volume. We have it in meters cubed. That's great. And our flow we are given, so we can just plug into our formula directly. So the detention time is equal to volume divided by flow. Our volume is 8,700 meters cubed, all over our flow, which is 233 meter cubes per day. Remember, we were given this value. We plug this into our calculator and we get 39 days as a detention time. Then that is our final answer. So we're going to have a detention time of 39 days for a lagoon of this size when we're receiving a flow at 233 meter cubes per day. Now, just a friendly reminder again, I know you guys have seen this before, but in case you're wondering how do we get days as the final unit, I will show you right here. So right now we have meter cube. We don't have a denominator, so we can just put it as 1. All over meter cube per day. And now remember, the trick that I like to do is outside by outside, inside by inside. So we multiply the outermost and we multiply the innermost. So meter cube is multiplied by the outermost, which is day, and the innermost is meter cube by 1. So our meter cubes, they cancel out, and then we have day over 1, which is just equal to day, which is the unit that we showed here. All right, so we have another problem here where we're discussing detention time, and it is saying that we have a treatment plant clarifier that is 30 meters in diameters by 3.65 meters deep. And it's asking us for the detention time of the clarifier in hours if the flow is 180 liters per second. Okay, so let's draw out what we're given. So we're given that we have a clarifier, and we're told, I'm just going to make this a bit better. We have a clarifier, and we're told that it is 30 meters in diameter, and the clarifier is 3.65 meters deep. Sorry for all the poor penmanship. My iPad is glitching a bit. All right, so we're told that we have this clarifier, we're given the dimensions, and we're told that we have a flow into the clarifier. So we have a flow, and it is at 180 liters per second. If you remember our flow, the representation for that is Q. You can watch one of our other videos where we do more in-depth problems around flow. So flow is whenever we have a measurement like liters or meter cubes over a period of time. So we have our flow into this clarifier, And the question is asking for the detention time, and it wants a detention time in hours. Okay, so let's look at the formula that we have. We know that detention time is equal to, and we have it up here, volume divided by flow. Okay. So immediately I know that I'm going to have to calculate my volume, and just looking at the units right now, I know that we're going to have to do some unit conversions. I see meters, I see liters, and I know that our final answer, we're looking for time, but here I see we have second. So we know that we're going to definitely have to do some unit conversions. But before we get into that, let's go ahead and solve for the volume of the clarifier. So if you remember, whenever you're calculating volume, we're going to have the area of the face, and in our case, the area of the face is a circle. So the area of the face is pi r squared multiplied by the depth, which in our case we're given as 3.65 meters. The depth or the length, I'm just going to leave it as length there. So we notice that in our formula right now, we have a radius, but we're given the dimension and diameter. So remember, how do we convert diameter to radius? Well, again, I'm a visual person. I like to draw things out. I know my diameter, we're giving it as 30 meters. Radius, we know, is half of that. So how do we get our radius? Well, we're just going to go with the 30 meters divided by 2, which is 15 meters. So we can plug that into our formula. We have pi multiplied by our radius, which is 15 meters. I'm always, no matter what the formula, what the question is, always putting in my units. Don't ever get lazy with something like that. That's where we see a lot of people make mistakes. You could do all this work, you could do all these calculations, and then you miss a unit or you get the wrong unit when you're plugging into the formula. So make sure you always get into the habit of doing that. Multiplied by my length, which is 3.65 meters. So I put that into my calculator. Remember that pi is 3.14. So I put this in my calculator and I get 2,579 meter cube as my volume. Okay, perfect. So we go back to the formula that we're given and we know that we have our volume. And now we're looking for our flow. So our flow we're given as 180 liters per second. Now I know that if I want to use this formula, I'm going to have all my units be the same. So I'm going to convert my flow into meter cubes. So if we have 180 liters per second, we know that there is 1,000 liters in 1 meter cube. This is something that you should just memorize. I'm going to put my liters at the bottom so that we can cancel it out. And now we're going to end up an answer with meter cubes per second. Now I'm not going to stop there because if you remember, the detention time is asking for hours. So let's also convert our second here into hours. So to do that, we know that in 1 hour, there is 3,600 seconds. Okay, so our seconds are going to cancel out, and we are going to end up with 648 meter cube per hour as our flow. So we have our flow in the right units, we have our volume in the right units, and now we can simply plug and play into our detention formula. So detention time is equal to volume over flow. The volume we found was 2,579 meter cubes, all over 648 meter cubes per hour, and we end up getting 4 hours as the detention time.